Okay, we're going to talk about an alignment. We're going to start off here with a fresh program open. We've selected our 100mm probe tip, and we are in guess mode over here on the right side. And currently we don't have any information measured at all. So here we are. We're going to grab the controller. I'm going to move the camera over so you can see what I'm doing here with the part. Let me adjust the camera down. Okay, here's our part. This is our hex block. And I'm going to start by moving the bridge up and bring it over in proximity of the part. When I get close, I'm going to go down to turtle mode. Slow it down. We want to have some nice slow hits on the top. We don't want to crash the probe. So there's a hit. There's a hit. Remember, 3 points make a plane. There's a hit. And I'm going to accept it now. The green button here. And now it says on the screen plane 1. So again, I'm going to move this to the second plane area. Move it down. Move it in. Our second point. Now our third point. And again, accept it. And now we are listing plane 2. Move this over to the third plane. Go down to turtle mode. Take 3 hits. Accept it, and now we have 3 planes. Okay, so let me show you what we have on the screen here. We'll bring this into view for you, and you can see what we have. Okay, so here on the left side now you see the listing of plane 1, plane 2, and plane 3. Our cursor is at the bottom, which is where we want it, so we can move on to the next feature. So what we're trying to do is align this plane, plane, plane. Here's something that looks kind of like that hex block. We have measured this plane, and this plane. So we have Z, we have our X side and our Y side. So to do an alignment, let's take a look at first what we have on here. If I hit Control Z, it will bring what we just did into view here. And you can see here we have tags that say plane 1, plane 2, and plane 3. And we have our little trihedron over here in the corner. It is not located on the part right now because we haven't told it where the part is. But you can see it's sort of faced the wrong way because plane 1 should be in this orientation, not in this orientation. So if I hold the scroll wheel down and push forward with the mouse, I can rotate this thing so that we get the planes in the right orientation. So now you see plane 1 is sitting flat, plane 2 is here, and plane 3 is on the side with Z plus pointing up, X pointing this way. Again, I can hit Control Z to center that a little bit. Okay, so now we want to do an alignment. We can do a manual alignment by either saying Insert, Alignment, New, right here, or, I'll just click at the bottom here. I come over to these little icons, and this one, if you hover over it, says New Alignment. They both do the same thing. They will open up this dialog box, the Alignment Utilities. Currently, it's calling our alignment A1. That's fine. We have our 3 planes listed in here, so that's good. So here's what we want to do first. We want to take plane 1, which was our top plane, and we want to tell it that that is our level surface. That is our top surface. So there's a little tag over here that says Z plus level. I'm going to click on that. So now it says up here Z plus is leveled to plane 1. Now the next thing we want to do is tell it we don't want this part to rotate around at all this way or that way right? We can stop it from rotating in the computer's mind by holding this plane down. It's as if we had a hand on this thing. It keeps it from moving this way or that way, right? So by selecting plane 1 here and saying that Z plus is going to rotate around Y minus. Now why is that? Here's our Z plus plane. Here's Y minus. We don't want this thing to rotate about Y minus. So we select those tags and we say rotate. Now it says Z plus is rotated around Y minus. Okay. And the last thing we want to do is tell it that this corner is our origin for everything. We want that trihedron to appear in this corner. So we go through and we say plane 1 is our Z origin. Plane 2 is our X origin. And plane 3 is our Y origin. Now, did we do that right? Where is our trihedron? Well, I don't know. That looks a little screwy to me. I don't think that ended up where we wanted it to be. So I did this on purpose to show you how we can get it wrong. And it's real easy to get the alignment wrong. So there's another way to do this. Let us just delete all of these. We can highlight each of these little features up here. Now I got most of this right, but I just wanted to show you how we got this wrong. We can select these planes in order, 1, 2, 3. Notice they say 1, 2, 3 here. These are the order of the planes we want. We can come down here to this nifty little button that says auto align. Okay, there's our trihedron where we wanted it. So where did we go wrong? Z plus was leveled to plane 1. Z plus was translated to plane 1, so that's our origin. Y minus rotated about Z plus. We got that right. Here's where we went wrong. Y plus is translated around plane 2, and X plus is translated around plane 3. You guys probably don't get this, but here's what we're saying. If I put this plane, if I say take this plane right here, plane 2, and plane 3, and put it right here, what we're saying is that it can no longer move in the X direction, right? So that stops that. And vice versa. If we put this here, we can no longer translate in the Y direction. So I just flipped those two there, but now you can see clearly what happened with that. To accept this, I just say OK. Now it's good to try to build a manual alignment on your own rather than use that auto align feature. Auto align is great, but it doesn't always work perfectly. And anytime you use these things, you have to look to see whether your alignment makes sense or not when it's there. Okay, so we have that. That is known as a manual alignment, and we could change this tag if we want to by editing it. We could just change it right in place here. We could say man A. And that's a good thing to do, is to let yourself know that that is your manual alignment. From there, we need to make a DCC alignment so that if this is executed again, it knows how to go through this whole function. Now this manual alignment here is something that the operator needs to do. And there are no instructions that tell the operator what to do written down anywhere. You can actually insert comments in this. So if I wanted to, just before that first plane alignment, I can come up here and I can say insert a port command. And I can put it in the report here so that the operator can see it. Okay, so if I come down here and say comment, This is for the operator, and I can tell them, please take 3 hits on the top plane. Now when this is run, the operator will get a little note here that says take 3 measurements on the top plane. So you would want to insert these comments in so that the operator knows what to do. When they've measured all of those, then the routine will go on from there. So now that we have this manual alignment in place, we want to do what's called a DCC alignment. So in here, there's a tag here that says DCC mode. So now it would be a direct computer control. Again, we would take those hits on the top plane, front plane, side plane, only we would take more hits this time. We would take probably more like 5 or 6 hits on the surface. So it really gets a good sampling of those planes. And again, we would insert a new alignment, and we would call it our DCC alignment. So once the measurement is done manually, then the computer will automatically go ahead and make those same hits, and the alignment will be complete in its memory. So there is yet another way to do this, though. Let me close this down, and let me start a fresh new one. We're just going to call this X block 6, just for convention. We're opening it up. We want to make sure we get our correct probe, our 100mm probe, and we're all set to go here. Only this time I'm going to import in the CAD drawing, which is in an IGES format, and I have it located here on the desktop. And we just say process, and boom, there it is. Okay, so I can rotate this around again using the scroll wheel so we can get a good view of it, and I can center it using Control Z. Now this time what I'm going to do is probe directly onto the surface using the mouse. So I can just click on it like this. And when I'm done, I can accept the command, and there's our plane, plane 1. Same thing here. 3 hits. Bam, plane 2. And we can move this around a little bit so we get a better look. And I can take 3 hits here, accept it. Bam, we have our manual alignment pieces in place. Again, I open this up, select 1, 2, 3, auto align it. It says not all 6 degrees of freedom constraint. So here's the problem. Up here, I did not go into manual mode. I am still here in DCC probe mode. We need to be in manual mode. Let's see if we can do the alignment now. And see, this was the problem that I created right off by not putting myself into the correct mode. So unfortunately, we don't have all the pieces of information we need to do it. However, it is that simple. If all of the things are set up correctly in here, we would have gotten our manual alignment. So it's just a taste of how this works. Obviously there are lots of pitfalls working in PC Demus, and it can be a little bit frustrating at times, but a little bit of practice, you too can make an alignment, and it's the most important thing you're going to do. Now, just one last note. Obviously not every part is shaped square or rectangular, so you can't always do a plane alignment. In fact, we could have gotten away with measuring a plane up here, measuring a line here, and just measuring a point there. And that would have given us the 3 things we needed to constrain the 6 degrees of freedom that are known to exist within a part. Additionally, not all parts are square. They may be angular. We could pick a circle feature, and that would constrain if we measure the center of this cylinder, that constrains degrees of freedom this way and that way, then we would still need to measure this plane to keep it from going that way. So there are a number of ways to create a part alignment, and as a programmer, it's incumbent upon you to figure out what the best way is. So there's just a little taste of alignments, and we'll go on from here.